Hello and welcome to the first lesson of Neuroscience 3505, Neural Data Science. Today we're going to be talking about variables and assignment. So I'm logged into CoCalc here, and I encourage you to follow along and type everything as I'm typing it. So I'm going to go into the lessons folder, and I'm going to go into the variables and assignment folder, and click on this variables and assignment.ipynb file. So this is a Jupyter Notebook file. That loads up, and you can see here the first cell is a markdown cell, so it's just information. And then down below there's another markdown cell, and then a code cell that we'll type in a minute. So variables and assignment, this is our first lesson in Python, so really introducing, what is Python? How do we actually interact with it? And the real question that we're going to address in this lesson is, how can I store data in programs? And our objectives are to write programs that assign values to variables and perform calculations with those values. And then we're going to correctly trace changes in values in programs that use what's called scalar assignment. It's a fancy word, but basically just assigning numbers to variables, kind of like you might remember from algebra. Okay, so in Python and programming more generally, we can use variables to store values. So variables are basically names, and we assign values to them. And in Python, the equals symbol assigns the value on the right to the name on the left. So you can see here in this code cell, our first variable assignment is we're going to create a variable called age, and we're going to assign to it, using the equal sign, the value of 42. And then the second line, we're going to create another variable called first name, with an underscore between the two words, and equals, and then Ahmed is going to be the value of that. And critically, you can see for Ahmed, we're putting it inside quote marks, and that's important. So numbers, like 42, Python treats as numbers, but when you want it to treat something as text, you need to put it inside of quote marks, and we'll come back to that in a minute. So I'm going to type this now. So I'm going to type age equals 42. And I'm going to point out here, you don't have to put spaces on either side of the equal sign. Technically, it'll still work without the spaces. But in terms of good programming style and just making your code readable, it's good to always put those spaces between the equal sign or any symbol you're using and the values and variables you're using. Okay, so age equals 42, then I'm going to hit enter, and then I'm going to do my other variable assignment. So first underscore name equals, and then in quotes, and it doesn't actually matter if you use single quotes or double quotes. Personally, I tend to always use single quotes. Ahmed. Okay, and then because we're in a Jupyter Notebook on CoCalc, we're going to press Shift and Enter to run that cell or execute that cell. And you can see there's a bit of a lag, and eventually we'll get some feedback that it actually ran. The lag is just because it's the first code cell we ran in this notebook, so it's actually starting up Python at that point and getting everything going. Okay, so a couple of things to know about variable names. Oh, and there we go. So you can tell when a code cell has finished executing, because in the square brackets here you'll see a number, and those numbers increment. So each code cell you run, the number goes up by 1, so you can sort of track where you are in the program. Okay, so critical things to know about the names of variables is that they can only contain letters, digits, and an underscore. So you can't use other kinds of symbols, and you definitely can't use spaces, because Python's going to see a space and think after that space is some new input or command. The other thing to know is that variable names are case sensitive. So as you can see here, lowercase age, uppercase A followed by GE, and then uppercase AGE are actually 3 different variables. Python will treat those differently, even though to a human those are all the same word, age. Variable names that start with underscores, like underscore Aaron's real age, have special meaning, and we won't actually talk about them right now, but the sort of take-home lesson there is it's good to avoid starting a variable name with underscores. Okay. So variables are how we store information in programs, and we can use them later. For example, we can use a Python command called print to print things out to the screen. And we can use print to both print text that we give it directly or the values of variables. So in this example, I'm going to say print and then open the parentheses. Parentheses are the round brackets. And it does matter if you use round brackets or square brackets or different things. So programming is very literal in that way. So print, open the parentheses, and you can see Jupyter automatically creates the closed parentheses at the end of it. So that's a nice thing that helps you sort of ensure that your code is formatted correctly. Okay, so inside the print statement, what goes inside these parentheses are basically what we want Python to print. So the first thing we're going to give it is first underscore name. So that's the name of the variable that we defined up above. So when we run this command, it's actually going to substitute Hamed for first name there. And then we're going to say in single quotes is, so it'll literally print out the word is. And then age without quotes. So now that's also going to be a variable. That's our age that was defined up above is 42. And then quote years space old, end quote, in parentheses. So when we execute this, we see it prints out Ahmed is 42 years old. So it's substituted in the value of the variable first name and the value of the variable age. And it automatically puts spaces in between the items in our list of things to print out wherever we've got a comma. And it also wraps around a new line at the end. You don't really see that, but if we were to run two print commands, each one would come out on a different line. Okay, so probably intuitively, variables have to be created before they're used. So up above we defined two variables, age and first name. We didn't define one called last name. So if I try to print last underscore name and run that, it's going to give me an error, specifically a type of error called a name error. Now you can see there's a lot of kind of output here that may look a little scary, but from the sort of newbie perspective of understanding these errors, the first thing to understand is whatever you did, it was wrong. Python didn't understand it. And it's a name error, so that's a specific type of error. And right at the bottom of the error output, you see name, last name is not defined. So basically it's telling me that I never defined a variable called last name, and that's why there's an error. We'll come back to sort of unpacking those error messages later on. Another thing to know is that variables persist between cells. So we kind of already saw that because up above, if I scroll up, we defined the variables age and first name in one cell, and then we used them later in another cell. So once you've defined a variable within this Jupyter notebook that you're running, it's in memory and you can call it at any time. That's good to know. It's also important to know that if you close this Jupyter notebook or you restart the kernel, we can talk about kernels later, then you'll lose everything that you have in memory and you'll have to start at the top of the notebook and run it again. And in fact, that's kind of a general rule that's good to be aware of, and that's what's talked about here, is that Python remembers everything that you've done up to a certain point. But it's good to arrange your notebooks in sort of a sequence so that you run it from top to bottom. So in this example, I've deliberately done something that won't work. So I say print myval, run that. Again, I get a name error because I never defined myval. And then if I say myval equals 1, okay, I've defined it, but I defined it after running that print statement. So I could go back up and I could click on this cell again, this print myval cell, execute it, and now it runs. But for me to come back and look at this notebook, or anybody else to look at this notebook, the logical thing to do is to start at the top and run the cells in sequence. So it doesn't make sense to define myval after the print statement and then say, oh yeah, I remember I have to run, go down and run that cell and then go back up. In CoCalc, it's quite easy to move cells around. You can actually just sort of click on one and drag and drop it. You can see that blue line. That should move it. No, that didn't. The other thing I can do when I go over that cell, there's these up and down arrows, so I can press the up arrow, and now myval is above print myval. So when I start the notebook again, that'll make sense. So I'm going to go slightly off script here and just talk about that, starting the notebooks. So you can see up at the top here in the toolbar, there's a menu option called kernel. The kernel is basically the Python process that's running, that's interpreting your code as you run it in this notebook. So that kernel started when I ran my first code cell, and I talked about it was sort of churning and taking a little while to execute because it was just starting up. Then it's running, everything I do is stored in memory within this notebook. If I go to restart kernel, what's going to happen is, it tells me I'll restart the kernel, it restarts that Python process, all variables will be lost. So it's a way to sort of get a fresh start. So I'm going to hit restart. We see this message at the top, and now the kernel has restarted, the notebook's restarted, and if, for instance, now I run this print myval cell, again I get this name error, so I actually have to go back and run the assignment again, myval equals 1, print myval, and then we get it. And I'm also going to need those variables age and first name, so I'm going to rerun those cells. There we go. Okay. So we've learned about variables. We can assign different kinds of values to variables like numbers or strings of text, like the word Ahmed. We can also use variables in calculations. So Python works as a simple calculator and even a complicated calculator. So here we're going to say age equals age plus 3. And again, you can see I'm putting spaces between age and the plus and the 3 to make my code more readable. And what this is going to do is take the current value of age, which we defined up above as 42, add 3 to it, and assign that result back to the same variable age. So now instead of being 42, after I run this, age will be equal to 42 plus 3, 45. And to prove that, I'm going to print age in years, sorry, age in 3 years, colon, close the quotes, comma, and then give it the next thing, which is the variable name age. Run that, age in 3 years is 45. Okay, and as I mentioned before, Python is case sensitive, so it treats upper and lowercase letters as totally different. So in this example, name with capital N is different from name with a lowercase n. So for example, if I try print age with a capital A, it's going to give me an error, whereas if I run print age with lowercase a, it'll give me the value 45. It's good practice only to use lowercase letters in your variable names. That's actually a convention bordering on a rule in Python. You can use capital letters in variable names. Python won't reject it. But from the perspective of good programming style, you should actually only ever use lowercase letters in variable names, because Python uses uppercase letters for specific purposes that we're not going to cover in this course. Okay, another rule, and again, this is like a guideline more than a rule, you can name your variable whatever you want. So you can see that I could say flabadab equals 42, and I could say EWR underscore 422 underscore lowercase y capital Y equals Ahmed, and I could use those in a print statement. So print EWR underscore 422 underscore YY, comma, is, in quotes, comma, flabadab, comma, years old. Run that, and oh, you can see there, you probably saw well before I did, flabadab, like that. There we go. Okay, so not surprisingly, Python is not only case sensitive, it's also sensitive to spelling errors. It's very literal. You do need to type things exactly the same every time. Anyway, the point here is that we could call our variables these confusing things like flabadab and EWR underscore 422 underscore YY, but Later on, you're probably going to be hard-pressed to remember what the heck flabadab and EWR blah 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 are. Whereas if you use intuitive variable names like age and first name, then it's much easier to use them later, remember what you called these things. It also makes your code more readable by other people. For example, if you're in a course like this one and you're submitting assignments for grading, the people who are doing the grading are going to be able to follow along with your code a lot more if the variable names are more obvious. And likewise, in the practice of science, if we want to do open science, share our results, make our results repeatable, and other people can sort of understand what we did, we want to write code that's interpretable. And if your variable names don't make any sense to anybody other than you, that's not very interpretable. Okay, so that's the basic sort of introduction to variables and assignment. And now there's a few exercises that we can go through. So what I'm going to do with this video is I'm going to introduce each exercise. I encourage you to actually pause, try and figure it out for yourself, and then unpause, and I will continue with the explanation. The nice thing about pausing is I'm very patient when I'm pre-recorded, and I'll just wait as long as it takes you, or you can sort of, get a hint. Okay, so first exercise, what's in a name? This is kind of a thought exercise more than a coding exercise. What's a better variable name, m, min, or minutes, and why? And again, think about, if you came into a lab and you had to read somebody else's code that was used to sort of work on a previous experiment, what would be the most interpretable for you to do? Okay, and the best answer there is minutes, because minutes is the most unambiguous interpretable name for that variable. Min is kind of interpretable in context, but min could also mean minimum, or minimalist, or Minnie Mouse. So minutes is a little more transparent. Okay, next exercise. Variables only change value when something's assigned to them. So if we, and this is sort of in contrast to if you're familiar with working with spreadsheets like Excel. So in Excel, if you create a spreadsheet, you've got some values in some cells, and then you have another cell that does a calculation based on those values. So say it takes the average of a bunch of numbers in a bunch of cells. If you change any of the values in those cells, Excel will automatically update the average to match. Whereas in Python, variables only change value when something's assigned to them, not automatically. So as an example here, I'll say first equals 1, second equals 5 times, so the star here, which is the shift plus the 8 key, is the symbol for multiplication, or times. So 5 times first equals 2, and then our last line is going to be print first is, first, and second is, comma, second. Okay, so here's where I want you to pause and think through what the values of first and second are going to be that are printed out. All right, so you can see that the output is first is 2 and second is 5. So critically here, we define first as being 1, and then we define second as being 5 times first. So when we run that assignment command, it says, okay, first is equal to 1, second is equal to 5 times 1, which is 5. And then we update first to have a value of 2, but that doesn't change the value of the variable called second, because second was already defined up above. So first is now 2 when we print this out, but second is still 5. Second didn't get updated to be 5 times the new value of first, or 2, otherwise the value of second would be 10. So basically, once you assign a variable, it has that value until you explicitly change that variable. All right, and then our final exercise for this lesson is about swapping values. And this is something that's used fairly commonly in programming in different contexts. So it's maybe a slightly confusing example at first, but it makes sense and it's useful to have experienced moving forward. So here we have x equals 1.0, y equals 3.0, and then we say swap equals x. So you can use variables in variable assignment like this, right? We saw that up above with like first times 5. So swap equals x. So now swap will take on the value of 1.0, because that's the value of x. X equals y. So now x is going to assume the value that y had of 3. Y will also still be that. And then y equals swap. So in this context, it's probably a little confusing, like why would you even bother doing this? But in other contexts with more complex programs, the motivation might become more clear. But basically what we're doing is we have two variables, x and y, which each have numerical values. Then we create a third value swap, which is kind of a temporary holding variable. Give it the value of x, and then we give x a new value, which is y, and then basically we're just trying to swap the values in x and y. So we're using this sort of third variable swap as the holding, and then y is equal to swap. So to see the output of this, we can say print, and then in quotes x, actually I'll say x equals, quotes, I don't know why it's double quoting like that, and then x, and then in quotes again, y equals, and y. We'll go back and put a space after the x because that's good style. Okay, so again here, hopefully this isn't too complex, but pause and think about what the end values of x and y are going to be that get printed out. And then the answer is x equals 3 and y equals 1. So as I said, we just swapped the values of x and y using that swap variable. Okay, so that brings us to the end of our first lesson on variables and assignment. The key points to remember are to use variables to store values. We can use the print command to display values. Variables persist between cells, so once you define a variable, it's held in Python's memory until you restart Python or quit. Variables have to be created before they can be used. They can be used in calculations. Python is case sensitive, so you need to be sensitive about the name of variables. Is it an uppercase A or lowercase a? Best practice is to use only lowercase letters, and then you're consistent with Python programming style and you don't confuse yourself. Variables only change their value when something's assigned to them, so they don't automatically update. If a variable was created from a computation from another variable, updating the one variable doesn't affect the other variable. And it's good practice to use meaningful variable names and not things like flabadab, unless flabadab means something to you and to other people. All right, thanks for watching, and that brings us to the end of this lesson.